doing great. Good to see you again.
Yeah, you too. Yeah, you too. So I'm going to kick into something today.
All right.
And what I thought this would do is this would lead to a little bit of back and forth in
Okay.
bits. This would also lead to a lot of myth busting outright
Nice.
straight away. So we
Nice.
are going to hit topics where people are going to go, no.
I love it.
And
I
then
love
we're
it.
going to hit the final piece that's important, which is why do we do it? So the topic for me today is standards, testing, and certification.
Nice.
So everybody thinks certification is just testing, and everybody thinks that testing is just to make sure that something's fine and that you just make it up as you go along, and you kind of go, it's a whole mess of unknowns. So what I thought I'd like to do is start from the top. Standards.
Nice.
Exactly. I mean, when we're talking about standards, where are we actually sitting with them?
Right.
Why do we use them?
What are
What's
they?
the point? What are they? In fact, what is an SDO? As much as everybody loves to use the acronym.
It's not a STD, it's a SDO.
Or today's STC, Standards Testing and Certification.
Oh, wow. Yeah, that's right. Yeah. Well, new acronym for us today. So,
Yeah.
SDO, as I know it, is a standards development organization, right?
Yeah.
So what?
That's right.
Now here's the trick question. Who can be an SDO?
Now, as far as understood, not everybody can be. I thought. Now you're gonna have to stop me on this one.
No, this is good. You're going down a good answer, but I'm going to give you a sort of an exception. So keep going.
So I didn't think everybody could. I thought you. Am I right in thinking that you should be a non-for-profit organization at the same time?
Okay, so here's where the it depends comes in. So it depends on where in the world you are sitting. So if you're sitting outside the U.S., most of the SDOs are very much tied in some way to their governments. If you're in the U.S., almost any organization could theoretically be an SDO.
Really?
Yep. An association, anybody could be an SDO. Now, that doesn't mean that they are. So the other thing about being an SDO is getting accredited. That means you meet certain guidelines. And in the U.S., you go to ANSI, which is the American National Standards Institute, which does the accreditation, and they can accredit whether you're an official kind of SDO. But you could be a trade association here in the U.S., and you can make standards for your members. In a sense, you are an SDO.
Yeah. Now that's been an education for me in that one. 100% education for me.
And
I had no, yeah.
yeah,
I had no record. No, yeah.
It's really weird, and like get a bit into the geekery here. Is that so? I love metrology or science of measurement. So in the U.S., the national metrology place is NIST, which is the National Institute of Standards and Technology. But NIST, as you know, is not the standards developer for all the standards in the U.S. Obviously not. They support a lot of the different SDOs, IEEE, ASTM, you name it, NFPA, all those, but they don't issue standards per se. Whereas if you go to overseas, to Europe, UK, now you get into those bodies that do issue standards. So in Britain, it's the British Standards, BSI, British Standards Institute, I believe.
That's right. That's right.
Yeah. And so they do issue standards, from my understanding.
Yes. Now, so for anybody is not clear about me, I was in academia for 11 years. So yeah, so long enough. And my experience on that side, where if you have a course, for example, you build the course. Then once you get the course, if you want it to be, let's say, engineering course, you typically go to get it accredited. So the procedure, the protocol is almost very similar to that of what we were just describing then. And yeah, the BSI is typical to what we'd use within that and the ASTM. So the ASTM compass we often used at the university as well.
Right.
Hence how I'd actually end up being involved in ASTM from that side of things.
Yeah.
Oh, that's very interesting.
Yeah.
Yes, that's interesting.
The other thing is there's, and this is kind of big picture stuff. We really haven't defined what standards are, but we'll get there. The other big picture thing for people to kind of get is how does it start? And how does a standard start? Even if you don't know what a standard is, how does it start? And that's where there is a bit of a difference also between the U.S. model, even though the standards developed in the U.S. apply globally, just like if a standard was developed in Great Britain or the EU, they could apply globally too. Here in the U.S., if your standards getting developed by NFPA, IEEE, ASTM, you name one, it comes from the industry. So it comes from a industry identified need. So in a sense, a very bottom up process. Whereas over in Europe and places like that, it comes from what's called a mandate. So usually you have either if you're in the EU, you have a mandate coming down from, let's say, the European Commission. Hey, we need something in this area. And then it, kind of goes through the processes to get developed through that.
Yeah, that makes sense. So, one of my myths that I'm looking forward to quashing on today's is so for us, obviously, we're members of ASTM,
right?
And I was literally just typing as we're talking, just to be sure. Obviously, it's 128 years. Recently celebrated its 128-year celebration.
Yeah, very old.
Now, originally, it was American Society for Testing and Materials, correct?
Correct.
Then in 2001, it became ASTM International.
Right.
Is that correct?
I believe so.
And the acronym was dropped, so it's just ASTM International.
Correct. Yeah. Yeah. They. I think it's still. If you're a sleuth out there, if you were to look probably in some of the government legal docs, you could probably still find it spelled out. But right now, from a legal perspective, the way I understand it, it's only ASTM International.
Yeah. No, it's one of those that I must admit, the amount of times I've been at events and things, and I'll say, look, do exoskeletons, and I'm also involved in ASTM, and then they'll say, what? You're not American? Well, yeah, it's a bit big. It's a bit bigger than just the US. It covers across.
Right.
And it's one of them myths. It's nice to squash.
Yeah. So now we have to go back to the hard question: is what is a standard? Since we've talked around this.
We have talked around it. So now to what I've always understood, and I think it's really just because I've been leaning on what we do more.
That's okay.
A standard is developed on an industry need, but it's an industry need that's delivered under consensus method of approach.
Right.
Now, I appreciate that that's not all standards that do it. And what this will do is this will bring a lot of people together to discuss and develop the ideal ways of being able to test something successfully, and also, if you will, cheat sheet the things that didn't work out.
Right.
That would be my clumsiest way of describing it.
No, it's very good. I mean, I think of it as, if you think of it in other contexts, I think of it as sort of, if you look at a market or a marketplace, or look at an economy, whatever makes sense to you, and you look at the infrastructure or the foundational pieces that make up that market or that economy, that's really what standards are. They give you that infrastructure in order to have sort of what we call a fair and open marketplace. And even some people will say an even playing field. It gives you sort of the basic infrastructure to work in a marketplace and to sell and buy products and services, where you can have some trust and confidence because of this underlying infrastructure. That, to me, is what standards ultimately are. Now, there's a lot of different names for standards. Like, there is a practice, there's a guide, there's a test method, there's a specification, but they're all standards. They're just different types of standards.
Yeah, which makes perfect sense.
Yeah.
Because if you were trying to, because in my mind, if you were trying to classify testing and guides how to do things or labeling and everything all into one area, you're missing a trick.
Right.
Just because there's just so much there. And I totally get that. And I think that's a good point to really kick into the idea of one of the biggest issues that we've faced on the exo side is exactly what is an exoskeleton.
Sure.
It's the exact same principle of that. We get on it and we kind of go, well, is it this? Is it that? And that's one of them things, isn't it? On the meetings that we have, it's nice to listen to everybody get so passionate about what they believe in.
Right. And that is part of this process. One of the things we're all passionate about is we believe exos can help in some way or another, whether that's help with work, help medically, help do something, help people live their lives. Everybody's kind of on board with that kind of thing. And, we see standards as giving this, as I sort of characterize it, this infrastructure in order for people to experience these technologies in a way that they can have some confidence that they will do something to actually help them, and in a way for people to have a better awareness of what they can and cannot do. So, it sort of ties in with, okay, the standards, which, okay, you have a guide. This is my synopsis of the different ones. You have a guide. I call that's what you read to get smart about that area. So if you have an exoskeleton guide, it tells you, okay, here's all the different tech that's involved with the exoskeleton, and it helps you kind of get smart about it. And then you have a practice, and there could be a lot of different practices, and they're basically talking to all the people in the industry and say, here we've cobbled together all these best practices for this specific thing. There'll be something, and we're going to put this so everybody's aware this is a good practice of how to do something. And then, our favorite, which is test method. This is how, okay, if you're going to test an exo, pick an exo or pick all the exos, this is how you would test it. Here's a procedure to test it. We all agree this is a pretty good way to do it. Then you get a little bit more serious, where we kind of are right now, is a specification. Yeah, we all have agreed how to test it. When we get to a specification, we're now starting to agree with, hey, if you do test it, you should get at least these results. Now,
giving you a baseline.
Now it's sort of a baseline, and some people tie specification with also sort of setting safety in a sense.
Mm-hmm.
So those are kind of the big ones to me, and that's kind of where we're kind of working. And then we get to the certification, which is we'll do that in a little bit, I guess.
yeah well, you just started to crack the egg on that side anyway with the testing. So I think that really starts to get into the area of where everybody will get a little bit different and a little bit antsy, and which way that we approach towards testing of things.
Sure. I mean, it's just, and I'll just say the obvious thing. Maybe people don't say this very much, but there is hope and fear around testing. There's hope that when I get my product, if I'm developing an exo, when I get my product tested, it's going to say my exo is awesome. My fear is it's going to say it's not awesome. It's going to give me bad press, and my company's going to crash. So there's this dichotomy that's always involved with this.
Yeah, you're always gambling between the two. Always between the two on the side. And that's where it can become quite interesting, where if you start to present new ways of being able to test, if you start to ask particular questions, some side you will get particular people who be like, well, I don't want to do that level of testing because I might not want to know.
Right. Yeah, the other thing is like, and this comes up a lot in conversations, is the cost of the testing. It's like it needs to be reasonable and affordable so that people will do the testing, and the testing doesn't overrun the revenue that would be generated by the product.
Yeah, very true. So if we were to move into a particular area of testing, what's interesting for me is if we're testing something like what we talk about with exos, if we're talking textile right through to hard material, this is where that fine line becomes quite interesting when you're moving into it. Now, we covered this before when we were looking at, if you look at exos, if you look at exos and hang on, let me see if I can just. Sorry, my feed's not working like I was hoping it would do.
It's okay.
Yeah, if you look at exos and you look at the way that we test things moving into it, if you look at a soft material, then you look at a hard material, what is that fine line? Now, some people argue that you should just test the components by themselves.
Right.
So if you test the components by themselves, individually by themselves, is that the right way to move about it moving forwards? Or should you test them all together in one go?
Right. Right.
What is that ideal way of being able to do it?
Yeah. Is it do you test components or you test the entire system? Absolutely. That is definitely a big question in the exo world of what is the best strategic way to do things and what's going to get you the best results as far as like, because ultimately we just want to know, okay, does the product meet these minimum types of, if we have specification, minimum baseline type specs. If a manufacturer's testing it, just using the test methods, and they want to see, what is the range of performance of it. That's also something that's good. We want to be able to be able to show that and use the right kind of metrics and sensors to do that. So both of those things are very important.
Yeah, they are. But I think because I'm just going to dive a little deeper on this one. I think one of the key things is when we're moving forwards on the realm of the exoskeleton is, rightly so, there's been a lot of work done looking at the way that somebody wears it and the way it interfaces with the human body. Then there's been an awful lot of work done to show how actuators will support. But there's not an awful lot of work done establishing that baseline of what is the minimum of it. What's the minimum expectation of it for it to be done? Now, you'll know this just because of some of the stuff that we've been on when we've been listening to another group that's been doing things, looking at establishing the minimum baseline for upper body exoskeletons.
Right.
Kind of shows that there's an awful lot to be known, as much as there's an awful lot of information already known.
Yeah, absolutely. Yeah, it's I mean, that's kind of how, when we're developing the test methods and the specifications, is like, we're relying on the data that has been produced by companies and researchers to kind of figure out where is the line and what's the best way forward in a lot of these areas. We also tie in a lot with, one of the things that's really important is not just the people that are developing the exoskeletons, but the users or the ultimate customers. What do they need the exoskeletons to do? And that helps inform what should be tested, how it should be tested, and what are those baseline specifications. So that's a part of this process. And what we try to do in standards committee is get this balance between producers and consumers. And that's really key to making a good standard.
Yeah, so if I was to relay that just slightly back, because you hit a really good point there of having consumers and users and developers in the actual in the rooms chatting these things out. So I think when we refer to consensus, the best way I think I've heard of consensus is if you had 100 people in the room, 80 people agree to what you're proposing moving forwards, but you will get some who kind of go, no, that's totally wrong, totally disagree.
Right. Yeah, and I was talking to somebody today about this whole thing with consensus and what do you do when you have differing opinions and you're talking with experts. I'm like, well, that's kind of normal. That's what science and engineering experts do all the time. We all have differing opinions. We do argue about different things about these different technical areas. But the thing is we go through this and we try to get like consensus, as we've said before. But what we're trying to do is, okay, what can we all kind of agree to? And then where are the differences at and why are there differences? It's like, okay, if we both have backgrounds in mechanical engineering and you're saying A and I'm saying Z, why are we saying A and Z? Does one of us have a different perception or maybe misperception? Or is one of us seeing something the other one hasn't seen and just don't know that it's not there? And so it's worth exploring all the opinions, especially when someone has a strong opinion about something in a technical area, because they may be seeing something that none of the rest of the folks are seeing, and we need to know about that because that turns out it's usually important.
Yeah, exactly. And I think getting this right and getting this covered over quite nicely, I think, is what leads to a better adoption.
Yes.
Because if you can get more people agreeing to what's going on, more people on your side, if you're not on your side, but seeing that way moving forwards, I think you end up with a better adoption of things. Because you'd covered earlier the idea of that you offer that not safety, but the idea what a standard does.
Yeah.
You offer that that I suppose it is safety. It gives people a lot more confidence in anything that they purchase. Yeah. So, for example, if you buy a motorcycle and then come out, if it says on the sticker, if you get on this bicycle and it explodes, it's your fault. Then that's not safety and confidence.
Yeah, that would make me pause a bit. But there's some
yeah, you kind of go.
Yeah. Yeah, it's like one of those things where I was just thinking, like, you have some reasonable expectations, and sometimes specs and test methods are about, and sometimes practices too, are about documenting these reasonable expectations. If you got in on the motorcycle or an automobile or a truck or whatever, everybody in the world would pretty much have a reasonable expectation that you would have brakes on that and you could stop it. And so if some manufacturer decide to make a vehicle without any brakes, that would be like, okay, why would you do that? And you better have a really good reason, right?
Yeah, that makes sense. So I am going to get to a big climax on this because I've been working up towards this moving forwards, but we'll get there. So if we take that from, let's say we've now got us testing, and we've now got a baseline of how we're going to test our product. It can be exo, it can be robot, it can be whatever for this example of what we got.
Right.
Then I want to get it certified. Now, the reason I'm getting to this discussion, the amount of times I listen to everybody say, well, why can I not just certify in my company? You go, I think you're missing the bill on that case.
You can do some self-certification, but I totally get what you're saying. Is like, there's self-certification and then there's third-party certification. So, and it's a spectrum of trust with that.
Okay. So if we get onto that case then, what I'm trying to do is just establish about what is certification.
Correct.
What is it? You see, from what I'm working with now, so obviously from what we're doing on the safety side at the minute, the certification approach, we're not exactly certifying with what we're doing right now.
No.
What we're doing, you, me, and many others on the committees at the moment, what we're actually doing is we're trying to establish a specification
Right.
of different ideals and different criterias.
Right.
So when are you in a position that you can certify?
Mm. Yeah, and in this, the thing is like there's a framework around certification. So what is, Bill's opinion on certification? What is it? So certification
Mm-hmm.
is can be many different things, but to me, it always involves some sort of testing or auditing. I mentioned the word auditing because you may be certifying a process or some sort of documentation. But in our case with Exos,
Okay.
we're really
Yeah.
talking more about testing of things, pieces of equipment, whether they're what we call passive or they're active. We're testing it to see if it actually does what it says it does. And so, and then the certification comes from, it can come from many different sources. So, like I mentioned before, you can self certify, which means, so you manufacture an EXO, you could take the ASTM or IEEE or ISO or whatever standard and say, okay, my team, we're going to test this and I'm going to self certify. I feel confident we did this correctly. We're going to take the liability and have the confidence say we self certified to this, and here, present some portion of those results summarized up for the public to consume or your customers to consume.
Mm.
That's sort of the, I'll say, sort of the base level of certification. And then it moves up from that. And the ultimate certification is really closer to what we call third party certification. So not only is it tested in an outside lab, but that lab has a special designation, which is called accreditation. So certification, accreditation. There's a lot of
Yeah.
words. I know jargon here, but all that's fancy wording for saying, hey, this lab has been checked by somebody else that they can actually run the test correctly. And not only can they run the test correctly, when they run the test correctly, they get similar results every time. So there's not a lot of, oh, I ran it Tuesday, I got 5. I ran it on Thursday, I got 50 for the same thing. No, that's not allowed. So the accreditation gives you not just, it gives you trust in the lab that's saying that something's certified. So there's multiple layers of trust built into this certification thing. And so you can sort of start at that self-certification level. And oftentimes I've seen for other products, companies will do self-certification in areas where it's nowhere near what I would call life critical. Nothing about this certification has anything that could possibly cause harm or permanent harm to any type of person or entity or something. So usually, if the closer something gets to, hey, if this goes wrong and this testing's wrong, somebody is going to get hurt really bad or die, the quicker you've got to be to third-party certification. So one of the examples we use all the time is fall harnesses. You think that they need third-party certification from accredited labs? Absolutely. Because if they don't work right, somebody is not going to be in good shape or probably die. So with Exos, we're sort of in this, in my opinion, we're sort of in this stage where we're starting to figure out what type of certification is needed for what different areas. Do you need all the way up to a third-party certification from an accredited lab for everything, or just some things? That's kind of where we are right now as we're building this up. So, long answer there.
That's a good answer, though, just because the amount of times I'll get anybody who asks me about it, And yeah, there's so much intertwined. It's like a spider's nest
Yeah.
of all different things or options getting into it. But that's a really good point. And I think safety critical components or safety critical
Sure.
assembly pieces are obviously the major pieces
Right.
when you're looking at these types of things and you're looking at them things moving forwards. Now, what leads me into the next statement with it, though, is we now get into a position where some components can be used a certain way.
Mm.
And we can end up with certification being termed out all over the place. And you kind of go, I'm just never convinced. I'm never 100% convinced with some of the component pieces that they're offering with. So some of the AM components, for example,
Sure.
some of the metal pieces, phenomenal. I've seen some of the testing that was done with them, really good. But then when you get to more of desktop printing and things like that, and being used in live components, you often do wonder: is there not a procedure that we should be allowing, that we should be looking at to set that up?
Right. Right. And it's also like right now a lot of things we're talking about is the testing and certification before something per se is on the market, or has just gotten on the market, and we're not we haven't really dived into the area of what a lot of people would call market surveillance, which is okay. You've had a product out there on the market, a user has used it for a certain period of time. Is it still performing the way it's supposed to? Does it
Hmm.
still meet the specs, or has
Yeah.
its performance degraded? And that is a whole different set of testing that could occur. And what happens. The other thing that we worry about a little bit, and we're starting to move in this direction, is what happens when you make a change to your exoskeleton model. How how significant is that change, and does that change trigger a recertification testing? So
Mm.
if you have model A and you make model A.1 or 8.01, like to use some software kind of lingo, and it's and all I did is I changed the color on the webbing. Okay, do I really need to do I need to spend $5,000 and get it retested, or let's not mess with it? But if I went in there and changed, like, well, I was using aluminum. It's called aluminum mat, and now and now I'm using some 3D printed PLA in there. Maybe we should retest that. I'm just saying.
Yeah. Yeah. Let's just double check that.
Let's just double check that.
Yeah. Yeah. No, I totally get that. And I think that comes back to the idea of when we were talking about exos on a construction site.
Yeah.
There, where you would almost want to over engineer, get it to outperform what it's been designed to do.
Right.
Against it. Now, I do know a lot of companies that do that. They actually do have a larger components on there that are really designed to be way over engineered compared to what the person who's
Right.
going to be wearing that device is going to be achievable with, giving them a solid platform to operate around. But but then my argument is if you're going to build it up with all that aluminium onto the person, onto the person, if you're going to shift that center of gravity, you're going to knock out that balance.
Right.
If you have one of our friends from the committees will be pleased that I'm saying this. If you don't consider gender biasing when you're moving forwards, if you don't look at how that center of gravity is being held by male and female, because let's face it, male, female, and ages drastically affect the way that somebody can move themselves.
Right.
And as I will name, as Mary would always tell us, what's important about when you're considering the skeletal structure for male to female is huge. If you have an over-engineered exo, you've got a whole nasty piece there. So then you get to the point of how do you write a specification to cover that?
Right.
It's huge.
Right. And kind of to use the construction analogy a little bit more, it's like, probably most people, our age, grew up with, seeing the yellow Tonka trucks, the toys and
Happy
stuff.
days.
Yeah, the Tonka dump trucks and everything. And so, you see a dump truck, in a construction site, and a lot of them are designed like those toys. And that is like this expectation. And you can use as thick and as heavy a metal as you need to make it look like a Tonka, giant Tonka, and be indestructible. And you just got to put a bigger engine in it, and it's all great and good. We need bigger tires, all that, everything you can make fantasy into reality pretty much in that area, and it works fine. The issue,
I have a really sorry to just cut you on that one. I have a just because you'd mentioned Tonka, I thought to myself, what is the factor of safety? So how over engineered is it? 5.
yeah, yeah, you can totally do that. Yeah,
You could do.
you can totally do it. And
Go.
the thing is with exos, and this is one of the areas that makes it special, is
Mhm.
an exoskeleton is mated with the person that's wearing it. So the more weight you put on that exo, that means that person is carrying more weight. And so as the person's shape and body changes too, that means the exoskeleton has to adapt. It goes both ways. It has to be a symbiotic relationship in order to work correctly. And so that changes what you can do as far as over engineering, because it's not like you're making an exo that's going to stand on its own, because there are some exos that can do that, and I would say sort of in the medical rehabilitation area, there's some exos that kind of stand on their own, and you can put extra weight and all sorts of things on it because the person wearing it is
Yeah.
not bearing that. But that's not common for a lot of the exos out there.
Yeah, and I mean for the stuff that I do from my side, at the moment I don't even tackle the idea of rehabilitation or medical, just because of the fear of balance and
Yep.
that over engineering of components. So I know exactly where you're coming from and that method of approach with it. I think as we move forwards, I think one key point for me, when people can when a flag can be put in the sand to say this is how we can certify 3D printed materials, I'll be super happy.
Yeah.
Super
I
happy.
know. I know that worries you all the time.
It- I know. Just for context, every meeting I always complain about this. Every meeting,
It's a
and
fair point though. It's a fair point.
it's it's just to the idea of that. I think, in fact, panning back to one of your podcasts with Nora when you were doing the Excellent Exo chat,
Right.
you once coined the idea of having several row of exoskeletons, tailored exoskeletons.
Right.
100% agreed. And the only way you could ever really do that has got to be with the AM approach,
Right. Right.
to have that contrast of both hard components and soft components. You're only ever really going to be able to do with the AM approach. But until AM gets to that position of saying 100% ABC, it's, I mean, don't get me wrong, as I said before, so, and the aluminums uh, that have been run, they can offer some level of security, but not all of it can. And
Well,
that's where it's a bit hit and miss at the moment.
well, and I will add to the Seville Row kind of concept is in my head, I kind of believe it's going to be a combination of subtractive and additive manufacturing that will be successful, because I think, with the combination of textiles and structural elements, and perhaps even some electronics and actuators and robotic elements, I think you're going to have a little bit both of those manufacturing techniques. So subtractive, for people, is basically just something where you take you've got a stock material and you cut away to the right shape. So take a piece of cloth and you cut away to the right
Yeah,
shape for a
that's right.
jacket. Additive would be is like, oh, I need this shape for my jacket, and so I would take the thread and build it right there to that shape. So build it up versus taking it off something that's already produced in a larger size. So, and I think you're going to see as you do these more customized products, you're going to have to use a little bit of both of those techniques. And so you do need those areas to be considered as we're doing the test methods and the specifications of like how do we make sure that as people are doing these different manufacturing techniques, we're testing this to make sure those techniques aren't introducing any kind of risk that we're not aware of, if that makes sense.
Yeah, that makes perfect sense. If you're noticing my camera's acting up, apologies. My feed is a little bit backwards and forwards today. It's been quite hot, so yeah. So apologies if it's going a little bit backwards and forwards.
I always blame Microsoft Teams. Microsoft is a great thing to blame pretty much everything on. So, why not?
Yeah, it really is. It really is. So yeah, I mean, anybody who follows me over LinkedIn, you'll know that this week I did a big post about students being involved and students getting involved.
Right.
This is really really an important factor from that side as well, because the more that we move down the road of certs, testing, specification, the more some of the bigger problems that are emerging with exos are not really going to be solved by us. They're
Right.
going to be solved by them next generations who will look and kind of go, well, it's obviously A, B, or C. And that's where, to continue that voice and to make sure it's there, you'll know that I am quite keen to get as many students to be involved as well,
Absolutely.
just to spark these discussions.
Right. And, and sort of tie back a little bit to what we were talking about with certifications, I just want people to realize one of the challenges out there, and we've got a lot of challenges in different areas. So, students looking for something challenging, come on, we got a bucket load of them. We can just pull
Yeah, we
one
do.
out any day. But here's another challenge, which is the testing, the specifications, and certifications, because a lot of our current test methods are based on somebody being in the exoskeleton. So you have to have human subjects. It's very difficult to get standardized human subjects. Haven't figured that one out yet. So that introduces a whole new variability in there, and then you start getting into the areas of population accommodation, which is how are you making sure you're getting at least we'll say the 95% percentile of the population or your potential customers, And so there's all these things in that. And then Matt's working on this and several others working on this. How do we do testing and the specs around the testing when someone's not in an exo, even if the exo's designed to be worn to use? There's a lot of interesting things going on there. So, the student stuff is great because they can be involved at any point in this, all the way from the research stage to, hey, I'm just interested in figuring out how to test this stuff, to,
Yeah.
hey, I want to try it out. I want to be a user. I want to try it out. I want to, go outside and do stuff with it. There's lots of opportunities for students and others to get involved in this area.
Yeah, I think just pushing on that same, if you know, if not anything but echoing, I think yeah, I totally agree of that. If you were to liken this to buying to developing an automobile, you go your suspension system. Well, you may go chassis, suspension system, engine. Let's stay on that remit
Right.
for that point. If you were developing just the engine, you have teams, you have companies dedicated to just the piston, the conrod, and the crank,
Right.
and then the head. So then once that's all been brought together, each company will test I only know this. My PhD was in this, so I'm boring on this one. So each company will test the piston, the conrod, and so forth.
Right.
Then they will send that away, and then companies will test the assembly. So they call it component testing to life cycle testing. So where it's been placed into its position, and that's even before a person sat in it.
Right.
And that is what we're trying to emulate, the exact same principle of that. Even before we strap an ankle onto someone, or we strap a spine onto someone, what is that baseline for mechanical testing? How do you know that date? What's the datum of the exo? What are you expecting it to be able to do? And I think that's where, even once you've established that baseline of what you're expecting it to do, to be able to move that next step and say, well, we're expecting it to be able to support somebody for, I don't know, 1,000 hours under certain conditions, then you've got to test it again to get them particular types.
Yeah, and the other thing is, like, we didn't really touch on this, but because most of the stuff we're talking about is really more of the physical hardware side of the thing. There's a whole different side of software and algorithms that have to also be tested. There are AI and other types of algorithms, machine learning, maybe even neural networks. I'm not even for sure, but there's a lot of different algorithms that are used mainly in the powered exos to provide control and also to adapt to the user. So that is another big challenge in the testing world, and this goes way beyond even exos. As you're getting more control mechanisms in different devices, even vehicles, that is adaptive. So your machine learning, your AI, whatever it may be, is learning every time it is used and is making small improvements or modifications. When does that get to a point where what was tested for certification has now deviated so far away from what it originally was that we really need to retest it again just to make sure it hasn't moved so far that it's gotten into some sort of risk area that we never anticipated? And that is a whole, the whole software algorithm side is a whole nother side that needs a lot of work that we've got to look at.
Well, I mean, I do think on our next podcast is something for us to really discuss, because when you refer to software and you refer to sensors and the ability of what sensors can do, I have a friend of mine. So I know this is slightly outside of what we're discussing, but a friend of mine yesterday sent me the new Microsoft Visual Code. Now it's free. It's free to download. You download it as no. So I started downloading it, and he said to me, "Have you tried using Platform IO?" And I was like, "Never heard this before in my life." Now I do a lot with microcontrollers. And a microcontroller, for anybody who doesn't know, is a tiny computer which will allow you to control actuators, to do all sorts. So Arduino, for example, is a microcontroller. And he said to me, have you tried using the Platform IO whilst coding? So sat there tapping away, and he said, now put a comment on. Now, you'll know from your mechanical days of when you write your comments, they're always really asked to be there, or else when you come back, you can't remember what the hell you were talking about.
Yeah, you don't know what this part of the program was supposed to do.
Exactly. So you write a comment in this code, and as you write it, the code then generates code for you to build on from the comment that you've put in the code as you're writing.
Crazy.
And when you think, it's like having a team of coders with you as you're coding.
Right.
So my point is with this is that he did a small experiment running this on an ESP32, what's called a C3. Now, if you've never seen them, they're about the same size as your thumbnail. They're tiny microcontroller. They run it on 3 volts, 3.5 volts, sorry.
Yeah.
And basically no ampage. They can go forever. They run on an ARM chip, incredibly powerful. And he ran a bit of code to see if he could run Platform AI live on the actual system. And for small pieces, it actually ran and it corrected its own code while running.
Wow. Amazing.
So That then gets you onto the principle of that if you're going to use AI attached to a human,
Right.
if a correction occurs and something goes horribly wrong, it's
but but it's also yes, but it's also the other side of it. Again, back to the Avengers, because we always end up there.
we do.
The other side of that coin is you could end up with Jarvis, which is what really makes the Iron Man suit work.
Yeah, I mean, let's face it. If you like that too, the Jarvis system, yeah, without Jarvis, he's gonna fall out of that sky. Well, he's never gonna take off. He's gonna
Nothing
try and
works.
fly and
It
go
just
straight through the wall.
nothing works. Yeah.
Yeah, exactly. Just because the one thing that everybody should remember is that something that flies has a lot of sensors on board and has a lot of things going on. It's not just a joystick.
Well, and think about this. Nope, nobody ever says anything about this, but there's no controls on Iron Man. It's not like he's punching buttons on his belly button. So,
Yeah.
I'm just saying, unless he's got some weird stuff going on with his body, it's Jarvis that's running the show here.
Yeah.
It's just doing what he wants it to do.
Yeah, exactly. That has to be. It has to be that way.
Yeah.
So,
that's
yeah, I mean,
pretty cool.
I think that's definitely a topic worth talking about. Moving on to the next one, anyhow, just because, yeah, it's a really hot topic that if we rush too quickly, I think it can be very dangerous. But at the same time, I think it can be absolutely revolutionary to enable people to be mobile.
Yes, absolutely. Well, I think that's a good place to wrap it up for today. We'll get on to Jarvis and AI and all that next time.
Absolutely.
If anybody has comments or topics for us to cover in the future, put them out there. We'll take a look at it and try to wrap them in.
Absolutely.